Hello everyone. In this video, we are going to see about stress, strain and elasticity. So myself, Dinesh Kumar from Hindustan College of Engineering and Technology. So here we go with stress at first. Okay. So stress is nothing but internal resisting force per unit area. Okay. Before that, we needed to know what is how the stress is happening. So if you take any object, okay, any 3D object. So in the blue color object, we are going to see what is the stress. So the force is going to be applied from the top of the object. Okay, so the line which I have drawn here is the particular area. Okay, any particular unit area. So in this particular area, a force is being applied towards downwards. Okay, towards down. So what's happening is the molecules present in the the molecules present in the object will try to resist the force. Okay, the object tries to maintain its shape. So what will the object do is it will tries to resist some of its force, resist the force. Okay, so that is happening inside the object. So that is what we call it as a stress. Okay, so the internal resisting force per unit area. Okay, so it indicates how intensely the internal particles of a body oppose the applied force. Okay, so stress is considered as a cause of deformation. So sometimes the stress causes also a deformation. Okay, if the stress is much higher or if the stress is much larger, so there will be some changes takes place because of its shape or internal resisting force. So second one is a strain. Okay, so strain is actually deformation shape. How much deformation have been done? So that is what a strain. So strain represents the deformation produced in the material due to stress. Okay, so initially we have seen how much stress is being applied in any object. Okay, in here the stress is being applied from the topward and from the upwards. Okay, through downward the stress is being the force is being applied. So what's happening here is due to higher stress, the position or the shape of the object have been reduced. Okay, the position of the object has been reduced to half of its size. Okay, so it is having a large strain. Okay, the ratio of change in dimension to the original dimension. Okay, so change in dimension to the original dimension. So what we are going to get for the higher stress is the strain will be higher. So if it goes for the smaller strain means the stress will be much smaller. So the strain will be also much smaller and the deformation also will be smaller. So that is what the example for a strain. Okay, so this is what the relationship between the stress and the strain. So stress is nothing but the internal resisting force by any object. Okay, internal resisting force by any object to the applied force. Okay, but strain is even though there is an internal resisting force, some deformation will takes place. So how much amount of deformation takes place is being calculated. So that is what a strain. Okay, so the last one is the comparison. In the study of engineering mechanics and material science, the concept of stress and strain is the foundation for understanding how materials behave under external forces. So this is the basic concept. Okay, and from the initial slide we have this is the elasticity part. So the elasticity is nothing but the property of a material that allows it to regain its original shape and size after deforming force is removed. So if any force is being applied on any object, okay, whether it is being applied or whether it is being uh, kind of an exponential effect. Okay, so even though there is a force, after deformation takes place, and after deformation again the object is trying to get to its original position. So that is what we call it as a elasticity. So the property of a material that allows it to regain its original shape and size after a deforming force is removed. Okay, the prime example for elasticity is a rubber band. Okay, or any kind of a material made of a light polymer material. Okay, so that is what an example for elasticity. So I think hope students have understood what is stress, strain, and elasticity. So in the upcoming video, we will see about the modulus based upon these things. So thank you for your patience. Thank you.